4 billion miles from the sun, a small frozen world just got its picture taken in a way it has never had before. Not a photograph, something closer to an X-ray of its entire sky. And researchers looking at the results are now asking questions they did not expect to be asking. Stay with me, because this is a real discovery, not a headline exaggeration. And if you want more science stories told straight, without the hype, go ahead and subscribe, because there is more coming out of the outer solar system very soon. To understand why this new data matters so much, you have to go back to how little we ever actually knew about this place. Pluto was found in 1930 by a young observatory assistant working through stacks of photographic plates by hand, comparing the same patch of sky night after night, looking for a single point of light that had moved. Almost every night, nothing changed. Then one night, something did. A faint dot had shifted, and that shift became Pluto. For decades afterward, it was taught in classrooms as the ninth planet, even though nobody had ever actually seen its surface. Then, in 2006, a formal vote by astronomers reclassified it as a dwarf planet, and it lost that title. To this day, it remains the only world ever discovered, celebrated for generations, and then formally voted out of the category that made it famous in the first place. For a while, that felt like the end of the story. A small, cold, unimportant leftover. New data made that assumption impossible to hold on to. Before any spacecraft ever reached it, Pluto was barely more than a smudge through even the largest telescopes on Earth. Scientists could track its orbit with decent precision, since that only required watching it move over years. But its surface, its composition, and whether it had any atmosphere at all, stayed genuinely unknown for most of the 20th century. Some early size estimates were wildly wrong, based on gravitational effects that later turned out to be measurement errors rather than anything Pluto was actually doing. Much of what people believed about this world for generations was built on guesses stacked on top of other guesses. In July of 2015, after a 9.5-year journey across billions of miles, NASA's New Horizons spacecraft flew past Pluto at more than 30,000 miles per hour. There was no second chance. No orbit, just a few minutes to gather everything it possibly could before continuing on into the dark. What it sent back reshaped the picture completely. A massive pale plane, shaped almost like a heart, stretched across the surface, smoother and younger looking than the ancient cratered ground around it. Mountains of solid water ice rose thousands of feet into a thin, hazy sky, frozen so hard they behaved more like stone than ice. Layers of blue haze rose hundreds of miles above the ground, visible even with the sun behind them. Pluto did not look finished. It looked like a world still changing. But New Horizons only got that one pass. Whatever it missed stayed a mystery for years, because nothing else was coming back for a second look. What researchers eventually needed was not another photograph. They needed a way to read Pluto's chemistry directly, from millions of miles away, without launching anything new. That is essentially what the James Webb Space Telescope was built to do. Webb does not fly past a target and take a snapshot. It reads light itself, splitting it apart into individual wavelengths to reveal what molecules are present and how warm different layers of an atmosphere really are. Pointed at a faint pinprick of reflected sunlight billions of miles away, it can describe an entire world's chemistry without ever physically approaching it. There was a real technical obstacle here, though. Pluto and its large moon Charon sit so close together from Webb's point of view that separating their individual heat signals had defeated earlier telescopes entirely. It was not that the signal wasn't there. Instruments simply could not tell how much heat belonged to Pluto and how much was leaking in from Charon. Webb's much larger mirror and far more sensitive infrared detectors finally solved that specific problem. Starting in 2022, once fully calibrated, Webb turned its attention toward Pluto, and what has come back since is closer to a full diagnosis than a picture. Go ahead and tap the like button if this kind of deep dive is what you come here for. It genuinely helps this channel reach more people who would enjoy it. The first major finding involves that same blue haze New Horizons photographed back in 2015. Scientists already knew Pluto's thin atmosphere was wrapped in fine hydrocarbon particles. What nobody had confirmed was what that haze was actually doing to the world underneath it. Back in 2017, a planetary scientist proposed something that sounded backwards at the time. On Saturn's moon Titan, Atmospheric haze traps heat and keeps the surface warmer. This researcher suggested Pluto's haze might work in reverse, soaking up sunlight during the day and then radiating that energy straight back into space, faster than Pluto's thin atmosphere could ever hold on to it. Instead of acting like a blanket, the haze would act like a radiator, pulling heat away from a world that barely had any to begin with. At the time, there was no instrument sensitive enough to test the idea. That changed once Webb's infrared instruments became capable of isolating Pluto's faint heat signal from Charon's. A research team using that data, with results published in 2025, found almost exactly what had been predicted 8 years earlier. Pluto's upper atmosphere really does appear to be actively cooled by the haze particles suspended inside it, and the measured temperature came out roughly 30 degrees colder than earlier models expected. Researchers now describe this as a genuinely new kind of climate, one unlike anything else observed in the solar system so far. Pluto is not simply cold because of distance from the sun. In a real sense, it may be refrigerating its own sky, and scientists suggest similar hazes could be shaping conditions on other distant worlds, or even hinting at what early Earth's atmosphere looked like billions of years before oxygen built up here. There is a second discovery tied to that same haze, and it is quieter, but just as unusual once you sit with it. Even the faint trickle of sunlight reaching Pluto is enough to break apart methane molecules high in its atmosphere. Those fragments don't simply disappear. They recombine into heavier reddish-brown compounds called tholins, which drift downward and settle onto the surface. New Horizons caught early traces of this back in 2015, and newer observations have kept refining exactly how the process unfolds. Here's the detail that tends to catch people off guard. Tholins belong to the same broad family of organic molecules some scientists believe may have once rained down onto early Earth, possibly contributing raw material for the chemistry that eventually led to life here. On Pluto, researchers estimate that same basic process has been running for roughly 4 billion years. A slow, continuous snowfall of biological building blocks, landing on a surface too frozen for any of it to ever spark into something alive. To put the cold in perspective, sunlight reaching Pluto is close to 1,000 times fainter than sunlight reaching Earth. Surface temperatures generally sit somewhere between about -387 and -369 degrees Fahrenheit, colder than anything ever recorded on Earth by a wide margin. At those temperatures, nitrogen, the same gas that makes up most of the air around you right now, freezes completely solid. The third finding tends to unsettle people the most, once it's explained properly. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift upward through its thin atmosphere, slip past its weak gravity, and escape outward. Scientists suspected this for a long time. What they didn't know was exactly where all that escaping material was going. It wasn't simply vanishing, something was catching it. Pluto's largest companion, an ice moon named Charon roughly 750 miles across, orbits in an extremely tight partnership with Pluto. Most of Charon's surface is unremarkable ancient water ice, except at its poles, which are stained a deep reddish-brown unlike anything else on the moon. Researchers long suspected a connection to material escaping Pluto, but lacked the tools to confirm it directly. The mechanism appears tied to Charon's unusually long seasons. Because of how it's tilted, Charon's northern pole spends multiple decades in total darkness at a stretch. That makes it an extremely effective cold trap, a place where escaping methane freezes solid onto the surface and accumulates for years before sunlight finally returns. Once it does, ultraviolet radiation and cosmic rays don't melt that frozen methane away. They break it apart and reassemble the pieces into heavier reddish compounds, locking the color in permanently. In effect, two worlds have apparently been trading atmosphere and color back and forth for longer than either one has had a name. Charon had one more surprise waiting. In October of 2024, a research team using Webb data confirmed the presence of both carbon dioxide and hydrogen peroxide frozen directly onto Charon's surface, a chemical combination never confirmed there before. The carbon dioxide likely came from underground material exposed by impact craters, while researchers suggest the hydrogen peroxide formed through years of radiation striking Charon's water ice. If this kind of deep space chemistry fascinates you as much as it does me, drop a comment, because it genuinely helps decide what gets covered next. Picture standing on the surface for a moment. because the details are almost hard to imagine otherwise. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth. You could look directly at it without discomfort. The sky would sit in a permanent grayish haze, never fully day, never fully night. The ground wouldn't behave like ice on Earth. Near 400 degrees below zero, water ice stops being slippery and behaves closer to solid rock, hard enough to ring almost like metal if struck. The atmosphere, roughly 100,000 times thinner than Earth's, would offer nothing to breathe, though the extreme cold would reach exposed skin almost instantly. And overhead, fixed permanently in the same spot in the sky, Charon would hang there, unmoving, the two worlds locked in a shared orbit around a point in empty space between them. The surface holds its own separate puzzles. In one region, New Horizons photographs something never documented anywhere else in the solar system. Tall rows of jagged ice blades made of frozen methane, some reaching more than 1,500 feet high, arranged in long parallel ridges. Smaller versions exist here on Earth in high-altitude deserts, rarely taller than a person. A 2025 analysis of the original flyby data suggests Pluto's version may wrap around as much as 60% of its equator. Elsewhere, a massive dark region, roughly the size of Alaska, stretches across the equator, colored deep reddish-black, where falling tholin particles appear to have piled up thickest over billions of years. South of the pale heart-shaped plain, two enormous isolated peaks rise out of the landscape that researchers still cannot fully explain. One stands roughly 13,000 feet tall, the other may reach close to 20,000 feet. Both have deep depressions at their summits with lumpy, uneven flanks resembling cooled lava flows, except there is no molten rock on Pluto. If these features are what they appear to be, they are cryovolcanoes, structures that once erupted not with melted stone, but with a slurry of water, ammonia, and methane forced up from beneath the icy crust. That internal warmth leads to one of the most debated ideas about Pluto today: the possibility of a hidden ocean buried roughly 100 miles beneath the surface, kept liquid by slow radioactive decay inside Pluto's rocky core. The evidence isn't a photograph, it's a pattern. Cracks and ridges across the surface line up in ways consistent with a liquid layer shifting slowly beneath the crust. And that famous heart-shaped plain sits above what appears to be a denser-than-expected patch of material underground. Similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa and Enceladus, moons of Jupiter and Saturn. If a body as small and cold as Pluto turns out to be hiding something similar, researchers suggest buried oceans might be a far more common feature of icy worlds than previously assumed, rather than a rare exception. Right now, there's no way to confirm any of this directly. There is no funded mission currently planning to send a probe back to Pluto. Missions to the outer solar system take the better part of a decade just to arrive, followed by a single brief window to gather data, and space agencies generally weigh that against closer missions that return results in just a few years. That trade-off means distant, icy worlds like Pluto often lose out in funding, not because interest has faded, but because the cost and timeline make them a difficult sell. For now, Webb remains the only working tool, checking back in every few months whenever Pluto swings into view. Pluto sits inside the Kuiper Belt, a vast ring of icy debris beyond Neptune's orbit, home to hundreds of thousands of objects and an estimated trillion or more comets. A handful of other bodies out there come reasonably close to Pluto's size.